I know, because it was the 30th anniversary.
Okay, so that makes sense, because I was like, man,
One of the buildings on campus, there was like
Okay, let's go ahead and get started.
and like one of the girls in my group was like,
How
"Oh,
many
I'm
here
sorry,
are
Amber, that was
boarding
just
here at
me
school
trying to mess with
or
the real
living
estate
close by?
Oh,
Everybody else is commuter? You know we have a gas problem, right?
Yeah.
I'm selling gas if y'all want some. $9.
Nine.
$100 a gallon? Okay, that's a good deal. Entrepreneur of the future. So what we're going to try to do today is to cover functions as much as I can, and I moved the quiz up so it's open. Functions is actually a short subject because it's a relation. So everything we study about relations has to do with functions as well. And if we don't have enough, if we don't have gas by Wednesday, then we may have to call off class, okay? But I'll keep track of it. I think the universities keep track of it as well. So we just see what happens. Okay? So, who can tell me what a function is?
In math, it's generally thought of as a relationship between x and y.
It's a relationship between x and y. What makes it not a regular relation?
I forget the exact phrasing. The x and y's are one-to-one.
Okay, it's close to a one-to-one. Guys, can you hold it down back there? Because it really does. Yeah, we're going to talk about a one-to-one, but really what it is, you're almost on it, for one in the domain, or the first set, there can only be one in the second set. However, you can have two of the first set go into the same one in the second set, so it's not a one-to-one. But the first item in each set, or each pair, can only relate to one second member. So for instance, if we were to create a relation like this, okay, with we're mapping integers over integers. Is that a function? It is a relation, isn't it? Okay. It's not a function, and the reason it's not a function, that notice that 2 is paired with 4 in this one, and 2 is also paired with 5. So the first member has 2 different second members. That cannot be in a function. If you remember from algebra, that's a function, isn't it? Parabola? Okay. And x is always considered the first value, and y is considered the second value. So if I pick a value of x here, how many values of y get paired with that? 1. Well, only that one right there, right? And if I pick the value of x down here, it only has one y value, okay? It's why we say that that's not a function, is it? Do you remember what we used to call the rule in college algebra? Remember the vertical line rule?
Vertical line test.
Yeah, the vertical line test. If we take a value of x, we find that there are 2 y's associated with that x, right? That's not a function. So that's why this one is not a function. We have a value here that's in the first set that is mapped against 2 different values in the second set. Okay? Now we're going to tend to use different drawings because we're not dealing with functions like we did in math. But we are using the same definitions. So if in your mind you are good at remembering the math pictures and graphs, then use them. We're not going to violate those at all. Okay? But here we may talk about something like this. And over here maybe we have A, B, C, D, and E. And over here we have F, G, H, I, J, K, L, and M. Okay? Now, if I draw a relation like this, is that a function?
Yes.
Yes, it absolutely is. And notice, that's good, because this didn't throw you, did it? This is okay. Just like in that parabola, we have a value of x here and a value of x here that share the same y, don't they? Yeah, that's okay. So the thing that's key over here is that each one of these only has one line coming out of it. Okay, it only relates to one value over there. What if I did that? Is that a function? Now this is where we differ from the math, because we would say that's not a function. The fact that E did not have a paired value over there is a violation of the definition of function. We just never saw that in math, really. Okay. So this is not a function. We call this the domain, and we call this the codomain. Now, somebody's going to say, well, wait a minute, isn't that the range? Let me ask you, is that the range?
No.
Why is it not the range?
You have values that aren't being used.
Exactly, very good. There are values that are not being used. When we talked about the range here, we would say that the range, this was from the origin, the range was only from 0 to infinity. Remember? We didn't define the range as all real numbers. The codomain of this is all real numbers, but the range is only the part that has pairs. Likewise, the domain is only the part that had pairs. When we define the log function, for instance, or the square root function, they both look the same. The domain started at 0 and went to infinity, and the range started at 0 and went to infinity. So the domain and the range are only the values that are included. Yes?
So would you call it a range if they did all have pairs, or would you still just call it the codomain?
If they all had pairs, yes. Yes. Or what I could do is just draw my circle so it included just those. You see what I mean? Okay. So what would we, going back to sets, using set language, what would we call a range in its relationship to a codomain?
It's a subset.
Subset, very good. It's a subset, yeah. It's a subset of the codomain, right? Might be the whole codomain, but it doesn't have to be. Okay. So, we have now the definition of domain, codomain, range, and function, right? Is everybody okay with all that? So let's look at this one. So first of all, is that a function? It is a function, isn't it? It's a special kind of function. It has a name. Notice that in my codomain, everything is covered, isn't it? or everything is used, we call this onto. Okay. And it kind of makes sense as to the word onto. If you are onto something, it's kind of like you've covered it, right? So when we use the word onto, an onto function is one where every member of the codomain has a pairing, or every one of them has an arrow coming to it if it's this drawing. How would we do this one in a set notation? Well, we have A and A. We have B and D, B and B, right? We have C and C. And we have D and A. And there would be the relation, and that's a function. And it's a function by the way we defined domain and codomain, okay? Which means that you might be able to define a set back to itself, right? Which is exactly what these functions do, because both the domain and codomain are a real number system. So that's onto. Well, let's change this around a little bit. Probably easier to start from scratch than do this. Okay. Let's say we have something like this. In fact, let's just put another value in here. Okay. Now, is that a function?
Yes.
Yes, it is a function, isn't it? And you're hopefully looking at this first, right, to see if it's a function. Is there only one arrow coming out of each one? That's what makes it a function, right? Is every one of these have an arrow? Yes. Okay, those are the two requirements over here. Now over here, I have one arrow coming to each one of those. We call that, that's the one-to-one that you mentioned earlier.
You don't have one going to five.
That's correct. And what it is for each one of these, there's one of these. For each one of these that has an arrow, there's only one of those. But you can still have a codomain bigger than the range. Okay? That's why I put that in there. Because what you're talking about is one more thing. Everybody okay with this? Now what do I have? Well, I still have one-to-one, don't I? What else do I have? It's onto. So one-to-one and onto has a special name, and that's called a one-to-one correspondence. Okay. One-to-one correspondence. Okay. So, where in computer science would you have a function?
Array list?
Where?
An array list? In an array list?
Array list?
Yeah.
Would an array list be just one? Well, are there two different sets in an array list? Can be, right?
Yeah.
Is there only one entry for the first going to the second? Or can it be more?
I think there can be more.
How about the index on an index file? Doesn't every member of the index only point to one record? Okay. So maybe that's an example. But an array list can almost be an index, can't it? So you're not far off there. Okay. Where else can we see a function? How many know about programming with modules? Okay. That's the way we should be thinking today. We should be thinking modules when we program. That comes out of software engineering. A module can be a function. You feed something into the module and expect to get something back, right? Do you expect to get more than one thing back? You could. You could have a situation where you feed something to a module and you get a list back of matches from a file or something. But a lot of times you feed something into a module expecting to get one value back. That could become a function. All right. So those are the applications in computer science. So now, have I missed anything? Okay, let's take a look at one other thing. The idea of an inverse function. Okay, so first of all, is that a function?
Yeah.
It is a function because each one of the numbers, which are the first in the pair, are only mentioned once, aren't they? So they aren't matched with two different letters. Okay, so it is a function. An inverse function is saying, can I switch all of these pairs and still be a function? Well, in this case, can I?
Yeah.
Does M have more than 5, or F have more than 3? C doesn't have more than the 2, or A have the 1, right? So the inverse function, if this is the F, then the inverse function would be A1, C2, F3, and M5. Now, what can be said about a function that can have an inverse function? What does that function need to be?
One-to-one correspondence.
It needs to be one-to-one for sure, doesn't it? Okay? And you're right, it needs to be a correspondence, because what would happen if I didn't show it up here, but I really had these two sets? And here is what I wrote up there. Notice that that is one-to-one, isn't it? If I try to turn this around, I would have a problem, because this now is not a valid domain, since I have O, which does not have a paired value. Okay? So therefore, I must be not only one-to-one, I must be and onto, which is one-to-one correspondence. Okay? Does that make sense to everybody? Okay. So what have we looked at here? We looked at the definition of function, right? We've looked at the difference between codomain and range. We've looked at one-to-one versus onto versus one-to-one correspondence. So has everybody pretty well got that? All right. That's about all we need for function. Okay. So, how would you like to look at some quiz questions? Would that help? Especially if we don't get Wednesday? Who disagrees? I was just kidding. I know. Okay, so let's look at some quiz questions and see if we can't figure out what the answer should be. Okay. So, there are more than one question. I can get all four at the same time. First of all, is this a function?
Yeah.
It is, isn't it? Is it onto?
No.
No.
Yeah.
It is, isn't it?
That's how it's one.
Notice that every value over here is covered. So think of onto as covered. So everything is covered over here. Is it one-to-one?
No.
So it's a function, and it's onto, isn't it? I think those are the questions we got. Now, all it is this a function? And the answer is yes, of course. Okay. Is this a function?
No.
And why is this not a function?
Four has two different values assigned to it.
Very good. You guys are getting it. Okay? So 4 only has 2 values coming out of it, doesn't it? So it's not a function. Okay. Is that a function?
No.
Who says yes? This is one of those things you hate to raise your hand, right? Who says no? Okay, why is it no?
Because what we went on earlier, four doesn't have anything.
Yeah, we have a value over here that does not have a value in the codomain, right? Remember, in a domain, you have to have all the values. Okay? Okay. So, now let's look at a mathematical function. The function f of x equals x plus 1, where the domain and codomain are the set of natural numbers. Okay, you know what the natural numbers are, right? The counting numbers, 0, 1, 2, 3, 4, 5. Some debate whether 0 is there or not, but 0 can't be there. It doesn't change this question. Is it onto?
Yes.
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 Okay, let's start with 0.
9 is going to show 10. 10
So if x is 0, what's y?
Things that are going to pop up.
1.
Why?
Uh-oh. Do you ever map anything onto 0? Do you see that? In the codomain, 0 doesn't have anything coming to it, does it? Because as soon as you put in 0 for x, y becomes x plus 1, which is 1. Okay? So therefore, it's false. It's not onto. Okay. So if the range of a function is identical to the codomain of a function, then the function is onto. True or false?
True.
Everything encoded.
Absolutely. By the definition of range, we said the range is everything that has arrows coming to it. And if it's the same as the codomain, then the codomain has everything with an arrow coming to it. Therefore, it is onto. Yes.
This is about the last question. You said 0 couldn't be mapped to 1 because onto, because 0 can't match.
Yeah, here's the thing. If I set up a table of x's and y's, okay? Now I start with 0, but remember to get y, I have to go x plus 1, right? So what's y?
1.
Okay, when x is 1, y is 2. From here on, you see it, right?
Yeah.
But we said, are the domain and codomain the same?
No.
No, because this one's missing 0, and you can't get to it.
For one of the ones we had, it was A, B, C, D,
Uh-huh,
and then the codomain was A, B, C,
uh-huh.
but D connected to A, and that was also an onto. How come D connected to A made it an onto, but 0 connected to 1 won't make it an onto?
I think it was 1 connected to it. In the picture, always look from your left to your right. Yeah, it always was there something connected to D?
So it was A connected to A, D connected to D, C connected to C, and then D was connected to A. So as long as 1 was connected to itself, so A connected to itself, it would make it an onto, even if D was connected to A. I'm sorry.
Yeah, I'm trying to picture it in my mind as you're saying it. Let me do it up here. Okay, what was in the domain?
A, B, C, and D.
And what was over here?
A, B, and C.
Okay? I see what you're saying. And what was A connected to?
A.
And B was connected to B,
Mm-hmm.
and C was connected to C,
Mm-hmm.
and then D was connected to A.
Yes, sir.
And that's okay, isn't it? And that's onto, isn't it? But notice, this is the Y side, isn't it? Okay? And over here, we said that the domain on and on, right? And over here, in the codomain, it was the same, right? But when we start mapping, what do we get? 0 mapped to 1, 1 maps to 2, 2 maps to 3, 3 maps to 4, 4 maps to 5, and so forth, right?
Oh, so because 0 on the codomain was left blank,
There you go.
then we don't, okay, cool.
And no matter how you try to get there, you can't get there, because every time you take a number, you got to add 1 to it,
Yeah.
right? Okay.
How about negative?
Can't have negatives,
Because it's not a natural.
not in natural numbers. Okay?
Okay.
Does everybody see that okay? Yeah, if you were to say integer against integer, you got a problem, don't you? There's this feeling that they probably don't map, but try to find that integer all the way down to the left, where you're adding 1 to it, you left something out. Because then you just drop another one, right? So that would be a philosophical question that belongs in a philosophy class, not in here. Okay. All right. Actually, it'd be a good one for a proof discussion. Okay, everybody got this one now? Okay. Okay, the cardinality of the domain of a function is equal to its range. Is that true or false? You remember what cardinality was in sets? It's the number of elements in the set, right? It's just counting the number of elements in the set. So, the cardinality of the domain of a function is equal to that of its range. False, right? What could we say about it? It's greater than or equal to, right? Okay. But if you're not onto, and you're not one-to-one, remember the range, though, have to have arrows coming to them, but still I could have 1 or 2, 3, 4, and 5, A, B, and C. Now, that's a function, isn't it?
Yeah.
And this is, by definition, a range, because there are arrows coming to every one of them. But the cardinality is not the same. This has a cardinality of 4 elements, 1, 2, 3, 4, and this has a cardinality of 3, 1, 2, 3. Does everybody see that okay? Don't forget what cardinality means, by the way. That's, again, data structure. You got to see things like that, concept. Now, this one changes a little bit. The cardinality of the domain of a one-to-one correspondence is equal to its range. Is that true?
Yes.
Now it is true, isn't it? Because there's only one in the range for one in the domain. Now we're talking range, not codomain. But even so, we could have substituted the word codomain here and still been okay, because we said one-to-one correspondence, which means we covered it, which means the codomain and the range are the same. Okay? Okay. Okay, so we've got several here. We're supposed to figure out which one is an onto function. Is this an onto function?
No,
Why?
because it does, after 1, the rest of them don't match to each other. So 2 doesn't match to 2, 3 doesn't match to 3, and
Now that's not a requirement.
that's not a run.
For onto, the requirement is that everything in the codomain be covered.
So then yes.
So it is, isn't it? Yeah. Is the second one onto?
4 is not.
Yeah, and by that definition, notice that this one fails, doesn't it? Because the 4 is not covered. Okay? So it's not onto. What about this one?
No.
It's not a function?
Aha, very good. It's not even a function, is it? If it were, it would be onto, but the problem is this 4 down here has 2 arrows coming out of it, okay? And number of function can only have 1 arrow coming out. Okay. Yes,
Wait, is that the third one or the,
I'm talking this one here.
okay, because I was about to say the fourth one is a function and it wouldn't be onto it if it was because, there's only, one, like, you know, you have like 2 going to 3 and 3 going to 1. So like 4 wouldn't, like, cover all of the codomain values.
Yeah, the 4 and the 2 are not covered, is that what you're saying?
Yeah.
But it's not a function because of it, you saw that too, right? Yeah. Okay, does everybody see that now? Okay. So we had only one of them that qualified, wasn't it? And it was the first one. First one's onto, isn't it? Yes, question? Okay. Yeah. Okay, so now we're looking for one-to-one correspondence. Is this one a one-to-one correspondence? And why?
You got
2 values go to 1.
3, 1.
Yeah, we got 2 values coming up here, don't we? Okay. Is this one a one-to-one correspondence?
Yes.
It is. Notice that 1 and 1, 2 goes to 3, 3 goes to 2, 4 goes to 4. There's only 1 arrow coming in, and there's only 1 arrow going out, and all of them are covered. And so then this is onto as well. So therefore, that would be a one-to-one correspondence. But let's go see the others. How about this one here? Is it a one-to-one correspondence? It's not a function because the 4, again, has 2 values coming out of it. So we don't go any further. It's not a function, you just stop right there. And the last one? Not a function either, is it? Okay. So the inverse of which function below is also a function. So is the inverse of that first one going to be a function?
No.
And here's what you do. Now consider this the domain and that the codomain, because a reverse function or inverse function goes the other way. And so you'd say, uh-oh, I've got 2 things coming out of 1. Think the arrow's going the other way. this second?
Function,
Yeah.
onto,
It's a one-to-one function.
It's a one-to-one onto function. Remember we said it had to be one-to-one correspondence in order to even be an inverse. And yes, going backwards, everything's fine.
No,
What about this one? And what's wrong with this one?
one has to.
Yeah, we have a problem here, don't we? Okay. But we also have a problem in the fact that the first was not even a function. So you can't have an inverse function if you don't start with a function. But for two reasons, you can say that one doesn't work. And the last one again, yeah, all kinds of reasons, right? Okay. So, that's the quiz. So what do you all think? Do you think you've learned enough today about what a function is?
Yeah.
Great. Okay. Well, like I said, it's kind of a short subject. Next week, we're going to start talking about graphs. What I might do is, if it looks like we're going to get gas, I may actually do an introduction to graphs on Friday. And here's the reason. I've got a conference next week that starts on Wednesday. I'll be leaving Wednesday. So we won't have class Wednesday and Friday next week. So maybe what we can do, if the gas thing works its way out and everybody's okay, is start graphs on Friday. But graphing, again, is a subject that can be covered in one period. So if we start on Friday, we can finish it on Monday easily. Yeah. Does that make sense? Okay. All right, so let's watch the news and see what's going on, and hopefully we'll be okay. Does everybody have any questions on the project? Have you started looking at it yet? Never get answers to that. What I'd like you to do is make sure you're looking at that project, at least read it through. And as you're reading it through, look for the things that you're going to need help on as you're reading it through, or questions you have. What does he mean by this? What's that mean? I didn't write that project, but I do know that there are areas in it where there is confusion. So if you spot something like that and you can't see clearly from what I said before on what that project is supposed to do, let's get it covered early, because I don't want to get started on the wrong track. All right? Okay. All right, if there's nothing else, then I will see you all on Wednesday.